back. So remember, I had technically asked for these to be on Friday. If you still have them with you and they've been signed by a parent/guardian, I would like these back today. If not, I would like these back by tomorrow. Okay? Remember that we are within our 2-week reassessment period. So the deadline for this is on the 29th. I would like these back by tomorrow because, ladies and gentlemen, I have parent-teacher conferences on Thursday. So when I meet with parents, if I don't have these back, then obviously I'll be saying, well, I'm still waiting on something that's a week past due here. Okay, Miles? So let's get these taken care of if you do not already have them taken care of. Okay? Your homework assignment was the 4.2 worksheet. We did, I think it was 1 through 19, and 1 through 15, and then something else. If you'd have that out, I'm going to walk around and I'm going to check that. I'm going to ask that you get started on these 3 problems up here on the board for me, please. Don't leave today without me talking about the assessment. Yep. Need one or not? I have one. Okay. Awesome. Thank you. Yep. Yep. Miles. Kane, here you are. Here you are. Yep. Yep. All right. Thank you very much. Okay, remember, in order to get partial credit, you got to have at least half of it done, so. You were absent, so if you want to show that to me tomorrow, Claire. Okay.
Back is big.
I just have like 4 because and the end it might be jagged because I was in the car. So it might be like
Francisco, do you have yours? Thank you very much. 1, 2, 3, 4, 5, 6. It's recording me teaching. She's still wanting to request you tomorrow for RTI then to work on some of this. I know you said something last week about that.
I don't know. I feel fine, but it's not for today.
Okay, let me know today, okay? The worksheet, yes. Do you have your...
Yes, right here. I'm on the last question.
Well,
Next.
it was a 4.2 worksheet. Do you have any work that goes with these?
And then there's another picture too.
Okay. Perfect. Thank you. I need to find it and let me know so I can come back and look at it. Okay. Thank you. Thank you, Caitlin. Hey, didn't you find that yet? All right, so I'll come around and check the other half here in a minute. We're going to get 3 people to come up to the board and get to working on this one. So problem number 1 is going to go to Delaney. Problem number 2 goes to Caitlin. And problem number 3 goes, let's see, to Quentin. So as soon as you are done, go on up to the board, please, and start working through those. Show your work that you've got. Okay. Just do you have your homework? Okay. Thank you, Chloe. Did you get anything past that? Okay, that's fine. Thank you. Do you have number 2 and 4 and 6? I see. All I see are the odds here. Nope. If I do that, then I'll put odds at the back of it. Okay. There we go. Perfect. keep flipping then. Okay, make sure you number which problem is which, though, so I know what I'm looking at there, okay? Okay. Do you have your homework? Yes. Yep, what's your question, Emma?
So for these, did I just do 2 times 2?
No, it's just the two. Whatever they have in common is what you bring down. If that's all they have in common, then that's all that you bring down. Yep. All right, Quentin, do you have your homework?
Yeah, these are the work shown, and then this is the after.
6, 7, 8. Okay, thank you. All right, so let's go ahead and take a look at these and proceed through. So again, today we're going to be taking all of this greatest common factor idea, and we're going to tie it into our new lesson today. And then we'll finally take an assessment on Wednesday of this week. It's been a while. Like I said, most of last week we were pretty much just kind of doing the necessary stuff for us to be moving forward here. Okay? So I like that we've had a couple different problems done in a couple different ways up here. Because remember, I don't need you to necessarily do it one way. I always suggest that if you do it one way, you just kind of get good at that. But understand that there's more than one way to find a greatest common factor. So in problem number 1, who had number 1 for us again? All right, so Delaney went ahead and she just started by listing the factors. Remember what a factor is it's a number that divides another number evenly. So if I were to talk about the factors of 12, our factors are 1, 2, 3, 4, 6, and 12. Okay, and our factors of 33, there are not a whole lot of them, but it's 1, 3, 11, and 33. So if we have our list of factors written out as we do here, we're simply looking for the largest one that shows up on both of those lists. So there are 2 common factors between these two numbers, 1 and 3. We're looking for the largest one of those. That's why my greatest common factor in this problem should be a 3. Okay? Now in number 2, Caitlin, you had this one, right? Yeah. So in number 2, Caitlin went ahead and did prime factorization. This is by using our factor tree. So if we begin with 18, 18 is even, so it's going to break into a 2, and then the other factors should be a 9. And then this 9 can break into a 3 and a 3 here. Okay, 28 is going to break into a 2 and 14, and then 14 is going to break into a 2 and a 7. So this might be kind of hard in the back to see it, but I'm going to read out what she has here. 18x to the 5th is a 2 with a 3 and a 3, and 5 x's behind it. And 28x to the 3rd is going to be a 2, and a 7 with 3 x's behind it. So when we look at what these numbers have in common, they each have a 2 on our list, so she circled that. And then as far as that's concerned, that's it. That's all the numbers have in common. Then you go to the variable part of this, and they have 1, 2, and 3 x's in common. So when we go ahead and find our greatest common factor here, we should have 2x to the 3rd. Okay, here's one thing that I'm going to point out as you are working through these with variables. Okay, and it's kind of a nice, easy, if you understand what I'm going to say here, it'll be a nice, easy way for you to check your work. When you're finding the greatest common factor, your exponent on your variable has to be the smaller of the two numbers. So like in this particular problem here, 5x's and 3x's, that means that they have 3x's in common. You can't have 4x's in common. You can't have 5x's in common because this doesn't have any more than 3x's. So it's one thing that as you start to work with these, I'll give you some strategies that you may start to consider, and that'll be things that you can kind of use to double check your work. Okay? And then for problem number 3, who had number 3 for me? All right, Quentin. So we took 16 and we broke it into 4 and 4, and then each of those 4s can be broken into 2 and a 2. 32, he broke into a 4 and an 8, and then that broke into a 2. The 4 broke into 2 2s, the 8 broke into a 4 and a 2, and then that 4 broke into another 2 and a 2. Again, I'm going to write this a little bit bigger so that way in the back of you guys can see this. So this would be 4 2's with 3 x's and a y. That's the first term. The second one should be 5 2's with an x and 2 y's. So then what you look at what they have in common. 1, 2, 3, 4 2's. So we're going to have 4 2's written out. They have 1x written out. And they have 1y written out. Some people asked, and again, this is a good question to ask on Friday, like, do my x's have to be on top and bottom? No, we're just looking for what they have in common. So then when I go to multiply these together, 2 times 2 is 4, times 2 is 8, times 2 is 16, and with 1x and 1y on it. And again, here's what I'm going to tell you. 3 x's and 1x. So the most x's they can have in common is 1x. 1y and 2 y's. The most y's that they can have in common is 1y. Again, we go back to, we're always choosing the smaller exponent in this particular problem. That's the answer that's part of our answer in this problem. Okay. Questions on those 3 to begin with? Now, I'm going to show something different because I'll be honest, I don't do either of these methods when I'm looking for greatest common factors. But again, I've done math long enough, like I've devised some own strategies that like maybe early on I didn't know for certain if they work, but now as a math teacher, like I know these work. So I actually talked with a couple of you on Friday and I gave you some different strategies to start to consider. And I'm just going to throw these out here, and if you don't understand what I'm doing, then don't do this. Like I don't want to throw this in and then all of a sudden have you be like, oh man, I really like that method, but I don't know how to do it. Then don't learn it. Okay? But here's a strategy that I've been talking with some of you about. When I'm looking for my greatest common factor of 12 and 33, I am going to find a common factor. I don't care if it's the greatest common factor. I'm going to find a common factor amongst those two numbers. So here's what I know. When I look at 12 and 33, those are both divisible by 3. So if I were to pull out a 3, and I'm going to pull that out over here on the side, divide each of these by 3. Use your calculators if you need to. What's 12 divided by 3? 4. Okay? What's 33 divided by 3? Okay. Now, when I look at these two numbers here, do I have any common factors between 4 and 11? No. These are what we call relatively prime numbers, aren't they? These numbers that I'm left with have no common factors. So guess what? That number is my greatest common factor. That's it. They're both divisible by 3. And when I broke them into smaller numbers, I found out that they had no other common factors, so I was done. Okay, what if they did? Great question, because now we're going to take a look at that with problem number 2. So what if I have 18 and 28? Okay, these are both divisible by? They're both divisible by 2. What's 18 divided by 2? 9. What's 28 divided by 2? 14. Do 9 and 14 have any common factors? Do 9 and 14 have any common factors? No. There's my greatest common factor. I know I still haven't gotten to your question yet, but give me a minute here. That's my greatest common factor. Now, 16 and 32. These are both divisible by 4. Let's just say that. 16 divided by 4 is 4. And 32 divided by 4 is?
8.
What goes into both 4 and 8?
4.
And also 4 again. 4 divided by 4 is?
1.
And 8 divided by 4 is? 2. Do these have any common factors left? No, they're relatively prime. Now, I pulled both of those numbers out. What's 4 times 4?
16.
There's my greatest common factor. So, I'll throw out another one just for you guys to consider as we look at. So if I were to give you, let's use 20 and 40. Give me a number that goes into both 20 and 48. 2. What's 20 divided by 2? Okay, what's 48 divided by 2? 24. Any other common factors between those two numbers? Another 2. What's 10 divided by 2? What's 24 divided by 2? Any common factors there? No. Multiply those two together. My greatest common factor between those two is 4. If you don't like this, don't use it. But I'll be honest, when we start reducing fractions, which is what we're doing today and tomorrow, this is actually a strategy that some of you are going to start to use. Even if you don't like it right now, it's a strategy that I emphasize. Don't spend a whole lot of time looking for greatest common factors. Just find common factors and work your way down until you get two numbers that we call relatively prime. When your two numbers are relatively prime, you've pulled out all of your common factors. Again, we'll see this more and more, but this is kind of a strategy that I just wanted to put in some of your minds because this is how I do it. Okay? I'll be honest, I don't spend a whole lot of time memorizing greatest common factors of pairs of numbers. I spend more time just finding common factors and then pulling those out when I get done. All right, let's take a look at the answers to your homework. Okay, so we did numbers 1 through 15, and then we jumped to 19 through 24. Please, again, make sure that you are reading the directions so you know what all of this stuff is asking you to do. It was not always just find the greatest common factor. Sometimes there was additional pieces to that. So in problem number 1, my greatest common factor should be 12. In number 2, my greatest common factor is 14. In number 3, my greatest common factor is 16. In number 4, my greatest common factor is 1. In number 5, my greatest common factor is 1. And in number 6, our greatest common factor should be 7. Okay, I'm going to pause after each set. So 1 through 6, questions that we've got on any of those. Okay, problem number 1. So let's look at 24 and 60. All right. Serena, did you do greatest prime factorization or common factors? Okay. So let's begin with this. Since the numbers are even, we're going to follow through with this until we can't anymore. 24 has to be divisible by 2. And the other factor then is 12. Again, if 12 is even, we're going to break that into another 2, and then to a 6, and 6 is even, so we're going to break this into a 2 and a 3. There's our prime factorization of 24. Okay, our prime factorization of 60 goes into 2 and 30. 30 can go into 2 and 15. And then 15 is not divisible by 2, but it is divisible by 3 and 5. So if we look at our greatest common factors here, we'd have 24, which is 2 times 2 times 2 times 3. And we have 60, which is 2 times 2 times 3 times 5. So if we're looking at what these numbers have in common on their list, they've got a 2 in common here. They've got another 2 in common here. And then they also have a set of 3s in common. So my greatest common factor is 2 times 2 times 3, which gives us 12. Okay? Again, I'm not going to do this for everyone, but I want to show you the other method we talked about just a minute ago. Give me a number that goes into both 24 and 60. 2. So this now becomes 12 and 30. Then what? Another 2 if I wanted to, right? Would be 6 and 15. What goes into both 6 and 15? 3. And that gives me 2 and 5. These two are relatively prime. You multiply those all together, You get 12. That's really all you're doing when you do your prime factorization. You're finding the common factors. That's all we're doing here. Again, it's maybe a little unorthodox, but that's how my mind processes that. Okay, any others through number 6? Okay, now 7 through 12. You needed to find the greatest common factor again, and then at the end of the problem, you needed to state whether or not they are relatively prime. Remember, what does it mean to be relatively prime? The greatest common factor is 1. All right, number 7. The greatest common factor in this is 2. So they are not relatively prime. Number 8. The greatest common factor is 13. So again, they are not relatively prime. Number 9. My greatest common factor is 1. So these are relatively prime. Number 10, my greatest common factor is 12. So they are not relatively prime. In number 11, our greatest common factor is 17. So these are not relatively prime. And in number 12, my greatest common factor is 1. So they are relatively prime. All right, questions on 7 through 12? Megan? Okay, problem number 7. Megan, how did you do your greatest common factor? Factor trees? Okay.
Oh, I see what I did wrong. I just placed it. Never mind.
Number 10 was 12.
Oh, because I got it.
You got it? Okay. Now, here's one thing I'm going to throw out right away. In problem number 7, they're both even. So what do you know has to be a common factor? 2. So automatically you know they're not relatively prime. Okay, now that still doesn't necessarily guarantee you that is the greatest common factor, but if the question said, are these relatively prime, you can answer that right away by saying no. All right, any others on 7 through 12? Okay, 13 through 15, so now we threw in the variables. Number 13, my greatest common factor should be 7m. Number 14 should be 2n. And number 15 should be 8t squared. Okay, any questions on those 3? Number 19 through 21, technically all you had to do is say whether or not these were relatively prime. Again, you're going to have to be able to do that by finding your greatest common factors though first. So number 19, are those 2 relatively prime? Yes, they are. Greatest common factor is 1. In number 20, those 2 numbers, the answer is yes, because again, the greatest common factor is 1. In number 21, the answer is no, because the greatest common factor in there actually turns out to be 3. Number 22, greatest common factor is 4y. Number 23, the greatest common factor is 11pq. There should be 1 p and 1 q in your answer. And in number 24, your greatest common factor is 4a, b, c. 1a, 1b, and 1c. All right, so questions on the last set of those? All right. Then if there are none, let's go ahead and put that away, please. And let's grab out. Got a little bit of time here, it looks like. We're done at 10 after. Let's grab out the part of our notes. All right, So now we're actually going to get into kind of the nuts and bolts of what we need to for all of unit number 2. Again, we have not technically done anything that is going to be directly assessed yet. And yes, we've spent over a week on this. But unit number 2 is centered all around fractions. So by the end of this unit, we would expect you to do really 3 different ideas. And this very first one is what we're going to focus on today and tomorrow. We need to be really, really good at equivalent fractions. Okay? Like great at writing, finding, and reducing equivalent fractions. Then, after we spend a couple of days on this, we're going to add, subtract fractions. Those are going to require greatest common factors, least common multiples, all of those ideas. Then we're going to multiply and divide. Those are our 3 standards that we're taking a look at doing. Okay? So we're going to begin today, and I'm going to break this up into 2 different ideas today. We're only going to focus on one of them. We're going to focus on our first definition today. Okay? Equivalent fractions. So let's begin with that definition and start talking about that as we get going here. So here is our definition of equivalent fractions. These are 2 fractions that represent the same number. Anytime that we are talking about equivalent fractions, we are talking about 2 fractions that represent the same number. And I'll give an example up here of a couple different ones before we move too much farther ahead. Okay? An example. We'll start with probably the most common fraction that we are comfortable working with is a half. The fraction 1/2 is the same number as, so I'm going to write that this is equal. It's the same number as 6/12. Those 2 fractions are equivalent. If you were to type, and remember, this is technically a division sign, so you could type this into your calculator. If you typed 1 divided by 2 on your calculator, it's going to give you 0.5. If you typed 6 divided by 12 on your calculator, it's going to give you the same decimal answer of 0.5. Those 2 fractions are equivalent. Now, one of those 2 fractions is reduced, and the other one is not, but mathematically they are equivalent fractions. Okay? Here's another example. Not all fractions that we look at are going to be what we call simple fractions. Sometimes they will be improper fractions. So I could give you an example of 21/6. Okay? This fraction is equivalent to 63/18. Okay? If you don't believe me, you could type it into your calculator again. If you took 21 divided by 6, it's going to give you 3.5. Okay, if you were to take 63/18, you're also going to get 3.5. Those 2 fractions, while they look drastically different, are equivalent to one another. All right, now, not all fractions, and you're going to see this by the end of tomorrow, not all of our fractions are just going to have numbers, which is why we can't become dependent on our calculator. Because I also would expect us to know this. 7xy over, we'll make this 10, is the same as 21x to the 4th y to the 5th over 30 x cubed y to the 4th. Those are equivalent fractions. Tomorrow, I will expect you to be able to go from one to the other. Okay? We're not just going to randomly be throwing out numbers. We also need to know how this works with variables as well. You might say, well, how did I go from here to here? I found the greatest common factor of this, which is what we just did as our opener, right? And I reduced it. That's what we're going to be working on. We're going to be finding greatest common factors and reducing these fractions as we go. Now, this is a big thing, and we're going to carry this over during 7th period. Here is one of my biggest pet peeves, is students who kind of fake their way through fractions, and they don't know exactly what they need to be doing. If I have two fractions that represent the same number, what we're doing is we're changing how it looks, but we're not changing its value. If we change something's value, they wouldn't represent the same number. So some of you might say, well, how did you come up with these equivalent fractions? Well, you got to think about, and this is what we're going to come back to during 7th period today, how can you change what something looks like without changing its value? Most of the time we're going to do this through multiplication or division. Now you might say, well, but hold on here. If I were to take 1/2 and I multiplied that by 3, is that going to change its value? Come on. Is this going to change something's value when you multiply it by 3? Yeah, it's going to triple its value. What is the only thing that you can multiply by and not change something's value? Hayden? 1. Really, when it comes to writing equivalent fractions and reducing fractions, all you're doing is you're multiplying something by 1. That sounds super, super simple. Except our 1 isn't going to just be the number 1. Our 1 is going to be things like this. 5 over 5. What is 5 over 5? This is 1. So we're going to have to be talking about, throughout the next day and a half, different ways of writing the number 1. Okay, because that's really what writing equivalent fractions are about. 7 over 7, what is that?
1.
It's the same as 1. Negative 10 over negative 10, this is the same as 1. 3xy over 3xy is the same as 1. Anytime that the top and the bottom of your fraction are the same expression, this is just another way of writing 1. And this is what we're going to be working on. And not only is it going to be numbers, it sometimes is going to be numbers and variables. Now, we're not only going to be multiplying, we're also going to be dividing sometimes. What is the only number that you can divide by and not change something's value? 1. So again, I could be dividing by something that has the same number on top and bottom. But what I want us to get at is, we're not changing the value, you're changing what it looks like. That's it. It's like somebody saying that I have 5 plus 3 and somebody else saying I have 8. Do they really have anything different? No. Does it look different? Yes. That's what we've got to start to process over the next day and a half here. All right, let's get the lids back on the calculators. I'll be around to collect those here in a minute. We're going to continue to build off of this during 7th period today. So this.